now.
Yeah, I'm ready. All right.
This meeting is being recorded.
All right. Okay. Good afternoon, everyone. Welcome. As you all know, or for those of you that don't know, I'm Mr. Johnson. I'll be your math teacher today. As you can see, we'll be focusing today's lesson on Standard 3084, which is represent and solve problems involving multiplication and division. Stephen, if you could hit that next slide for me, please.
Sir.
More specifically, right, our daily objective today will be using whole numbers to multiply or divide and be able to identify the unknown whole numbers in the equation. So determining unknown whole numbers in multiplication or division equations. Next slide, please, Stephen. So before we get started, I kind of just wanted to brainstorm with one another. So we'll be working as a group. Stephen, this is where I would have my thing open and type. I don't know if you'll be able to type in it, which is fine. But we'll be collaborating as a class, right? I think you mentioned it, Stephen, where this lesson is pretty much the teacher serves more as a facilitator, because I was kind of following along the social cognitive theory where students are going to be asked more to collaborate and work with one another, as that's one of the things that we learn as students learn when they're working with their peers, more so rather than the teacher lecturing and instructing. So here we would be filling out the know, want to know, and learn part. Down below, I have some key terms that we've probably already gone over in previous lessons. So at this point, I would ask the students to either ask if they know the multiplication, the ones that are missing for the definitions, and if they don't know, we would put it into the want to know or learn or what we already know. Okay, so we could go on the next slide. We don't have to do that.
Perfect. Yeah, and I could not type in there. Sorry.
Yeah, no, I know. No worries. Thank you.
Yeah.
So moving along, before we get on to the lesson, the focus lesson of the day, I wanted to gauge some prior knowledge, give students a chance to show what they already know. So engaging prior knowledge is interpreting products and quotients. That's how you pronounce it. So example one, as you can see, is for us, but Ben, if you want to go ahead and kind of just read through A through C for us and what we have. As you can see, we have flowers, right, and a group. Or yeah, if Ben, you want to read it, or
Name of groups of name of the groups, 4, size of each group 5. B, 4 times 5 equals 20. And C, there are 20 flowers together.
Okay, so basically what we did, right, we just looked at any groups, was how many flowers within each group, the numbers that we know, we're able to use multiplication function and find out that it's 20. Good job. So example two, right, very similar to the problem, but this time we don't have the answer. So for one, how many fish are in each tank? I know it's a small picture, so I don't know if you guys are able to see. I'll go ahead and answer that one for us. So it's 4 fishes per tank. So the next question will be, how total fish are there? So we know there are 4 fish and that there are 3 tanks. So trying to find that known, what we would do, Stephen.
Perfect. Yeah, and I like that because that gives me multiple kind of multiple outlets to solve that. I can count the fish one by one if I want in each tank. I can use the multiplication they're using and notice that there are 4 fish in each tank with 3 tanks. So I can do 4 by 3. So yeah, that's great that it gives me multiple options to solve that.
Okay. Yeah, and I think I answered number 3, how many fish tanks total, which everyone should be able to see is 3. So if you could hit the next slide for me, please, Stephen.
Absolutely.
So then we would just go over some practice problems, working together to answer the questions and solve the equations. So I'll kind of just lead from here and you guys can chime in. So how many unknowns in problem 1? So basically how many question marks are on there? Either one of you guys want to shout it out?
Yeah, perfect. I see 1 unknown in question 1. We have 3 times 6 equals 1 question mark, which is our unknown in there.
Number 2, you have 7 times question mark equals 35. So then you put it as division, 35 divided by 7 equals question. How many unknowns? Yeah.
Yeah, so there'd be 2 unknowns in there, then eventually I would have the answer, which 6 times 3 is 18, right? If I'm correct. And then obviously 7 times however equals 35, they would figure out that it's 5 for both of those. All right. Thank you, guys. You can put the next slide, Stephen.
Got it.
And then just trying to relate it to real world problems, I kind of just put together a word problem. So I'll go ahead and read that. Marissa has a part-time job at a frozen yogurt shop. Marissa works 3 days each week. Each day she works 4 hours. Marissa makes $10 each hour she works. So we have some information, which would be our knowns, and then have 3 different questions where we would have to fill in the unknowns. So number 1 is how many hours does Marissa work each week?
Perfect. So for that, I would look up back into the question that you have all the information I need up there, which is perfect. We know she has a part-time job. We know she works 3 days a week. We want to know how many hours she works. We know each day she works is going to be 4 hours, which is going to lead us to either 4 times 3 or 4 plus 4 plus 4.
Excellent. Good job, Stephen. And then obviously, if that was a little bit too easy, we got a little bit more of a difficult question for our more advanced learners. How much money does Marissa make after 1 week of working? I don't know if you kind of want to take the lead on that one, Benny.
How much money does Marissa make after 1 week? $120, because since part 1 is 3 times 4 equals 12. And then you know she makes $10 per hour, that would be 10 times 12 equals 120. So 120 bucks.
Yep. Excellent. Then the last one, if Marissa wants to buy her dad a gift for Father's Day that costs $250, how many hours would she need to work before she could afford the gift? Stephen, you want to take us home with that last problem and kind of just tell us your thought process, how you would figure that
Yeah,
out?
sounds good. So I would start by looking at the overall cost of the gift that she wants to buy, which we have noted up there for $250. I would look at first then what her pay is per hour. So I can see as well, back to our original question, that she makes $10 each hour. So I would do 10 into 250, which would give me 25. So I'll know she'll have to work 25 hours in order to pay for this $250 gift.
Awesome. Benny, do you want to chime in on any other way that you would be able to figure that out, or you would do it the same way Stephen would?
I would do the same way as Steven. I agree with him.
Okay. Then the last slide, I believe, would be just, closing. Practice problems will be available on Google Classroom for those that you need that need extra practice. There will be a quiz on this lesson and concept next week. And then thank you all, and that'll be it.